Okay, so in your HL class, you learned about induction. And when you learned about the method of proof by induction, you probably learned this method of proof using 5 steps. And those steps were to state the claim being asserted, and generally we write that claim as P sub n. And then show that it's true for an initial value. Typically it's n equals 1, but it depends on how your problem statement is set up. Okay, so we then assume that P sub k is true for some n equal to k. And here's the key part that is the difference between mathematical induction, also known sometimes as weak induction, and strong induction. So with strong induction, this sum becomes that we assume that P sub k is true for all 1 less than or equal to I less than or equal to some k or k minus 1, etc. Not etc., depending on what we're going to do for our next statement. So we're looking at all these values of I. This 1, again, depends on the initial statement. So in strong induction, this is our step 3. So assume that P sub k is true for all I values between 1 and k. So then if that P sub k is true, then the next expression, P sub k plus 1. So here if we had said k minus 1, then we would be using k minus 1, P sub k here. And it just depends on the problem statement as to which of those is easier to look at. And just like weak induction or regular proof by induction, we're going to use this statement that we've assumed is true to help us show that the next one is true. And then if that's the case, we do the same thing. We make some sort of summary statement that if this ends up being true, then that must mean that this was true because our initial value was true. And so our initial claim is true by proof by induction. And you don't have to say proof by strong induction when you say it's true by proof by induction. So in our next video, we're going to look at an example of how this works.